In this problem, we're going to learn to calculate the cost per day of dosing liquid alum used to precipitate phosphorus out of a wastewater stream. Well, let's go to the board and see how to work this problem. Well, the problem reads, liquid alum, which is 9.1% aluminum, is being used to remove phosphorus from an activated sludge effluent. 7.5 milligrams per liter of aluminum is required to give adequate removal of phosphorus in this effluent. They want us to calculate the daily cost of liquid alum given the following information. And they gave us the plant flow, which is 1.8 mgd, the specific gravity of the stock solution, the stock alum solution is 1.32, the concentration of the liquid alum solution is 49%, and they gave us the cost per gallon of liquid alum, which is $1.62. So if we can calculate the pounds per day of this liquid alum that we're using, we can then calculate or use that answer to calculate how many gallons per day of liquid alum we're using. And once we know the gallons per day, we can use this equivalent of $1.62 for every gallon to solve for the cost or the dollars per day. Well, let's get started using our normal approach. They want us to calculate the daily cost of liquid alum. So that's our unknown. We're looking for dollars per day. So we write that down. And they tell us that the liquid alum is 9.1% aluminum. So that's our active ingredients. We want to write that down. Our active ingredient is 9.1% aluminum. The aluminum is what's reacting with the phosphorus to precipitate it out. And they tell us that we're dosing 7.5 milligrams per liter as aluminum. So when we plug this into the problem, we're dosing, our milligrams per liter will be 7.5 as aluminum. So we write that down. Now, because we're dosing as aluminum, we need to take into account what percent of the total is due to aluminum. And that's the 9.1%. When you look at the chemical compound of aluminum sulfate, as listed here, you can see that aluminum is only a small part of the whole compound. You've got aluminum, sulfate, and you've got 14 water molecules. So by weight, the aluminum is only 9.1% of the total. But when we dose, we're dosing liquid alum, which contains all of that. So when we use our pounds formula, we'll have to take into account the 9.1% that's due to aluminum. So our normal pounds formula reads as follows. Pounds per day of liquid alum will be equal to our flow in million gallons per day times the dose, that's the 7.5 milligrams per liter, times 8.34. And that's how much a gallon of water weighs. And when we're dosing in single digits or even double digit milligrams per liter, we assume that it's 8.34 pounds per gallon of solution. We'll see where we have to use specific gravity later when we have a strong solution where the weight of a gallon of that solution actually weighs more than a gallon of water. But in this case, we use this basic pounds formula, and to take into account that portion that's due to aluminum, we divide by the percent active ingredient. So this is a variation of the pounds formula. Well, now that we have the formula we're going to use, let's plug in the numbers they gave us and do the math. So plugging in the numbers, we can see that our pounds per day of liquid alum is the 1.8 mgd, that's our flow, times the 7.5 milligrams per liter, times the 8.34, and then we divide by the percent active ingredient. In this case, it's 9.1%. But remember, whenever we use percentages in these math problems, we enter them as decimals. So the decimal form of 9.1% is 0.091, or as I wrote here, 0.091. Well, now that we have all the numbers plugged in, we simply punch that into our calculator, and we see that we're dosing at a rate of 1,237 pounds per day. So that's how much liquid alum we're using. Well, now we can plug this number back into a variation of the pounds formula again to solve for how many gallons of that stock alum solution we're actually dosing. So the formula that we're going to use is pounds per day equals your flow in gallons per day times the concentration in percent times 8.34. And in this case, since we're dealing with this alum, which weighs more than a gallon of water, we take into account the specific gravity, which in this case is 1.32. We're now going to rearrange this formula to solve for gallons per day, because we know how many pounds per day. That's the 1,237. We know the concentration, that's 49%. They gave us that. And we know the specific gravity, that's 1.32. That's given in the problem as well. So let's rearrange this formula and solve for this gallons per day. And once we have the gallons per day, we multiply by the $1.32, or excuse me, the $1.62 per gallon, and we'll have our answer. So rearranging this formula, we take our pounds per day and we divide by all the terms on the other side of the equal sign except for the gallons per day. So we're going to bring our concentration to the bottom of the other side and the 8.34 as well as the specific gravity. And that will give us our gallons per day. So here we simply rearrange the formula. If you don't understand this, we have a lesson called Working with Formulas that explains how these formulas can be rearranged. Well, now that we've solved for gallons per day, it's simply a math problem. Let's plug the numbers in and do the math. So again, we solved for our pounds per day, which was 1,237. And then they gave us our concentration, which is 49%. And again, we enter it as a decimal, so 0.49. 8.34 is the weight of a gallon of water. But relating that to the weight of a gallon of liquid alum, we have to multiply by the specific gravity, which is 1.32. So now we have it set up, and when we plug this into our calculator and do this math, we see that we're dosing at a rate of 229.3 gallons per day. So that's how much liquid alum we're dosing. Well, now that we know how many gallons per day, we simply do a unit conversion using our $1.62 per gallon, and notice that the gallons go away and we're left with dollars per day. And when we do this math, we come up with approximately $372 per day. And that, my friend, is how this problem is solved.